everybody. What we're doing today is we're going to start using our first simulation, and most of our simulations are going to be PHET simulations. PHET is a university in Colorado. This is their lovely little logo down here that you will see on many of these simulations that we're going to be working with. This is our collision lab. We're going to be using this multiple times. We'll be using it in the Explore 1D for 3 of ours, and then the Explore 2D as well. So we're going to click on the Explore 1D first. This is going to open up like this. As a matter of fact, let's do a quick little reset down here. This yellow reload button at the bottom here will reload your screen so it comes up exactly how it will come up. So anytime you want it to get back to the factory settings, if you will, it is this button down here that you're looking for. So when you get to this, it's going to start out just like this. And the main thing you want to do is you need to know which parts you have to be looking at. So oftentimes you're going to have a whole list on this side of things that you can or can't look at. For example, your velocity, your momentum, your center of mass, your kinetic energy, and all of the values. Then it also has a reflecting border or not. The difference between that on this one is the reflecting border means it's going to bounce back when it hits the wall. And if it doesn't have a reflecting border, it's going to continue past the edge of the screen. In our first case here, we are going to be using inelastic collisions because we want to do a hit and stick collision. But when we do our rebounds, we're going to have it be 100% elastic, which is up on this end. That's the here. And then you've got your constant size, which makes them the exact same size, or you can go back to having them being different sizes. Personally, if you put all of this information on the screen, this is way too much for me to look at. I can't, it's way too much information. So I'm going to take off the center of mass. I'm actually going to take off the velocity because this whole point of this portion of the course is looking at momentum. I might leave my kinetic energy there. I'm going to get rid of my values because there's another place where we can see them, and I don't actually care about reflecting borders. So that cleans up what I'm looking at very well. The only problem is I cannot see what the values are. And so that values data is pretty important. However, I can also get that data down here. Let me just move myself over a little bit. So if you get these values down here, you don't need to see them up there during your screen. That is a personal preference as to which one you want to use. Totally up to you. The last box I'm going to click here is this momentum data, and what I like about this one is it does give you the total momentum all the way through, and especially at the beginning of this portion, it's good to have that there so that you know that the momentum is staying constant. And it's a nice visual representation to help you understand that even though 1 and 2 are changing, you have your total here. This is also beautifully written as a vector diagram where you have your momentum of the first added head to tail to the momentum of the second, and your resultant vector, which is always the vector that we're worried about, is drawn from the tail of the first to the head of the last. So this is also a beautiful representation of a vector diagram, which you're going to have to draw a million times. So now that we have this all set up, we've got this area cleaned up, but seeing what we want to see, we're going to click our play button. The interaction happens, and we're going to pause it. So we have here, our momentum has changed, but our total has remained the same. We have our momentum diagrams up here, and we have all of our velocity and our mass data down here. We also left on our kinetic energy. So if you remember what it was from before, I believe it was 0.44, and after the collision, it was 0.2, so you can also tell from that that it is an inelastic collision, which we've set it at, but it's again another representation to help you get that into your head. With this, you're going to be playing around with changing the mass, changing the velocities. If you want to change the mass, you can click on it and just click in specific numbers here. Same for any of these that you want to do. If you leave that more data off, there's a sliding scale, not as precise, might be more fun. All right, If you have any questions about this, please contact me via email, and we will continue learning from here.